Imagine in 30 years, and you know this world will be filled with robots. Robots moving around, like self-driving cars, like airplanes, drones, and industrial robots. So how do they know where they are, and how do they know to avoid each other? You know, there are cameras, but cameras are not good enough. Cameras are in 2D. They make mistakes. So you really wanted to be safe? You need something better. That's what we're offering today. The laser sensor is called LiDAR. It's basically a laser sensor to give you 3D scanned image of what's around you. Let's take self-driving cars as an example. This will be a typical setup for a self-driving car. You have cameras, you have radars, and you have LiDARs. You know what? A typical self-driving car, a LiDAR takes up to 50% of this self-driving car's cost. That's outrageous. Like, when did a sensor cost half of the whole assembly's price? There's a reason for that. Because LiDARs are the best way to detect your environment. Well, if you compare to cameras, cameras are basically guessing what's going on by comparing the size. But for LiDARs, they are direct measurements. They're like using a measuring tape to know the distance from the type flight. Compared to radars and cameras, they function in most of the conditions. For car safeties, if you can function in all of the conditions, that's a king. People are willing to pay a huge premium for it. This is what we're offering. We developed this 360 LiDAR that can detect your environment, and it's put on top of a car, and it works all the time. This is the actual scan image from my LiDAR. You can see people really clearly, you can see the car. This might not be as good as a camera's image, but remember, you're living in 3D. 3D is much safer than knowing your environment in 2D. And this is our unit on the Shanghai Auto Show, and this is mounted on top of a car. We're already shipping those to our early customers, major car OEMs, and major self-driving car developers. And our ambitions is much bigger than this. This curved LiDAR is so expensive and so big, it can be only used for autonomous cars and HD maps. But we're also working on a smaller version. This newer version we're about to release by the end of the year, it's small and it's affordable. This can be mounted onto industrial robots, drones, and also production cars. And this will be the great future for a lot of those robots that's coming along in the coming 10 years. But we're also more ambitious than this. Eventually, our goal is to put a little chip basically onto any moving parts. They can be so small but so powerful that they will fit it onto smart homes, smart cities, onto the back of your phone. Also, if you imagine you're using AR, being able to know your 3D environment in real time gives you a huge privilege. Like in 10 years, when you sit there, you will be looking at a screen here from your AR where there's no screen because my LiDAR knows where this wall is supposed to be at. We're able to do this because we have a phenomenal team. Our company was founded in Silicon Valley a couple of years ago. We scientists from Stanford, MIT, Tsinghua, and we also have very experienced engineers from Apple, from Lam Research, Huawei, Western Digital. We also have a good track record of making different laser sensors. We team up with DJI on a natural gas inspector drone, and we already shipped a lot of units of it. We're great with making those devices. And I have a few founding members. Kai went to Stanford studying optics, laser. Xiang Shaoqing, he worked for Apple for many years on their iPhones, and he's great with electronics. And I'm CEO of the company. This is part of our team. This is all I have. Thank you very much.
All right, good job. Judges, questions, comments?
You're primarily selling a device right now, is that correct?
Yes.
Is there also a way to monetize and own the data that will come out of the devices?
Great question. So for now, we're selling this optical device. And we now focus on hardware itself because there's a belief that if you want to have the best camera, the natural first step is to make a great camera like Leica. And then when you know you have the best device, you can put that together with a great Photoshop. So for now, we're providing raw data to our customers. It's called point cloud. But we're also working on perception software to be able to track cars and people and to be able to group different objects and tell the cars to what to do next. And in the next step, because it's a two-stage thing, the first stage is building the best sensor. The second stage for us is to be able to use enormous amount of sensors to collect data. Because we believe the next barrier for autonomous driving is to be able to own a lot of data. As the sensor provider, we have the natural privilege to collect a lot of data, and we're not giving them up.
I have a very fundamental question from an outsider. So when I look at your product, what is the difference with what car companies or other tech companies are? They probably have the same technology or they're working on it already. And when I look at your chart, you might have advantage on night vision or distance or 3D modeling. What is the barrier from them catching up to your tech?
Okay, you have basically two questions. So the first question is comparing to other competing technologies like radar and the camera. How do I know LiDAR will beat them in every aspect? The answer is I don't, and it cannot. The proposal here is to use LiDAR to complement camera and the radar. So this chart, I'm not trying to take one slice, but rather my proposal is to use laser sensors to bundle a sensor fusion system so that in every scenario, there will be one sensor fully functional, and that's ultimately what your car wants.
Right, I can't see the slides very clear. This is solid state, right?
My current version is solid state hybrid, so it's not full solid state. But my the middle one and the last one will be solid state.
Right. So let's say, let's see if you're ready to ship this in volume. Let's say in 2 years from now.
Can you define volume?
Right. Volume meaning you can, it's a commercial.
I mean
commercially
quantity.
available. Quantity, right?
How big? How big is?
Tell me how much you're charging.
I'm going to ask the cost, right?
Yeah.
So when you start to ship in volume, what is the cost of, let's say, 32 ray?
So I cannot discuss specific pricing, but here's the thing. So the
$200 or $2,000?
my solid state, the goal for solid state for vehicle LiDARs will eventually be in around $100, $200, and this is a reasonable price for Tier 1 and OEMs. And my ultimately consumer LiDARs, they will be in the range of $10 to $50. In volume. When I say volume, when I ask define, not the concept, but the quantity, we're talking about millions of units.
How much have you raised to date, and what do you think it will take to commercialize this technology to the point of actually getting revenue?
We are creating revenue, so we are already shipping our units.
Okay.
I should have said that.
Okay, sorry, how much have you raised to date?
A little over $20 million US dollars.
Okay. And I guess you can't give us numbers on revenue at the moment, but...
I would love to shoot you an email on that.
Okay. All right, thanks.
I still have a minute.
Well, since you have time, I'm going to ask you a few more questions.
Yes.
It's good to see you
Thank you.
again.
Yes,
So
I
David, maybe you can share, your thoughts in terms of how you pivot from your previous business to what you're doing.
Thank you.
And how your original technology would allow you to actually build your current hybrid solid-state LiDAR. It's a really tough technology. Global startups are all trying to address this, trying to bring it down from 10,000,
Good. I have 40 seconds. So the 20 seconds for the first question. Since last time you saw me, I was making drones for natural gas, and then we realized that it's a very limited market, as you already pointed out. So we realized that laser technologies can be applied to a lot of industries. So I spent 4 months surveying the market for LiDAR, where laser sensors can be used. And then eventually we target for 3 things. A, the thing has to have very high technological barrier, which this fits. B, this has to be a standard product. A lot of those laser sensors, they work for specific industries. We don't want that. And C, this market has to be huge. So when you combine those three, we realize that the laser sensors for cars are the best for the time being. But also, as I said, we do have greater ambition eventually to put our laser sensors onto every moving robot. So I have to follow you on the next question in email. I guess that's it because my time is up.
All right, that's it. Good job. Give him a round of applause.
Cool. Yeah, thank you.